Assalamu alaikum. My name is Khalil Khan and I am assistant professor at 𝗙𝗿𝗵𝗺𝗺 Kazakhstan. So first of all, I would like to say thanks to the organizing committee of ICCI who gave me this opportunity to give this brief talk about the topic, which is screening with sound in a framework for congenital heart disease diagnosis in rural areas of Pakistan. So this is a common problem in Pakistan, an issue with the abnormalities of the heart, with the structure of the heart, and due to that reason, most of the kids, and specifically in rural areas, they don't survive. So after some time, they normally die. So it's a very common problem in Pakistan. So we try to address this issue with the help of AI. So let's talk about this. Now, what is CHD or what is congenital heart disease? So, congenital heart disease is basically a problem with the structure of the heart, and this is not a very explored problem, not only by machine learning, computer vision experts, but as well as by the medical practitioners. And the reason is its complexity. It is a very complex problem. So far in the literature, there are 35 different kinds of diseases, 35 different kinds of CHDs which are reported, and most of these problems are with the structure of the baby heart, with the not functioning properly of the baby heart, or maybe with the issue of the heartbeat, for example, rhythm, and so on. So, and statistics show that this issue is very severe in undeveloped countries particularly. So worldwide statistics show that this CHD is not only a problem for Pakistan, for undeveloped countries, but even some developed countries are also facing the same issue. Here we can see that even in China, the CHD reported is out of 1,000 live births, 8.2 are facing CHD. Similarly, for Bangladesh, it is more severe. It is 25 out of 1,000 births. For Pakistan, it is 15 out of 1,000 births. And worldwide, it is 8 out of 1,000 live births. And here we can also see that the death rates due to CHD out of the total death rates worldwide is 16.49%. Yearly CHD reported in Pakistan is 60,000, and kids who are not treated due to poor diagnosis in Pakistan is about 60%. So there are different reasons that why the kids are not treated properly. I mean, like one of the main reason is we have very few hospitals, very specialized doctors who can do surgery of this serious problem. The other issue is the cost of the surgery. It's too much. So every person cannot afford the surgery of this disease. We have some numbers for CHD in Pakistan. So we have only 4 hospitals that can perform surgeries according to WHO standards. And similarly, families who can afford the cost of CHD is also too much. Like normally it is around 3,000 to 4,000 USD. So all the people cannot afford this much amount. So we have 5 to 6 million births per year in Pakistan, which approximately equal to the 40,000 or to 60,000 newborn with CHD annually. Another main problem is the lack of awareness in Pakistan, specifically in the rural areas, in the areas which are far from the cities. So normally the CHDs are there are problem with the CHDs. I mean, since we don't have specialized doctors in those rural areas, so and due to that reason, normally the kids die due to CHD without diagnosing properly. So recognizing this gap, we started work on this exciting project about 4 years back, and still we are doing some research. So we are trying to develop, you can say, an AI stethoscope which can detect the CHD specifically in rural areas, in areas which are far from the cities. Now the question is this topic has been fully explored by medical practitioners and machine learning expert? So my answer, and from my experience, since I am exploring this topic since last 3 to 4 years, the answer is no. So there are some works from medical side. I mean, like how many kinds of CHDs we have, how we can perform the surgery, etc. But for machine learning experts and those people who are working in machine learning, they have not explored this topic fully. So actually there is a gap between machine learning people and medical practitioners. So due to that reason, the topic has not been explored fully. And the other reason is the complexity, the nature of complexity of this topic. Like for a person who is from computer background, it's very difficult to understand the anatomy of the heart and to understand the functionality of the heart and all the complexity behind. So due to this reason, the topic is not that much. So it's an innovative problem actually. And the other main issue is the unavailability of a database. We don't have a large amount of data on which we can train a machine learning or a deep learning model. There are some data sets available, very few data sets, but training a deep learning model on those data sets is not that much productive. And unfortunately, most of these data sets are not available for free for research. So actually these are the properties of some hospitals and some researchers. So is there any prototype develop in Pakistan? So not only in Pakistan, but to the best of our knowledge, we did not found any tool, any prototype which can detect CHD easily. I mean, just initial diagnosis of the CHD, not going to the complexity or the types of CHDs. Now, there are different kinds of modalities or signals which have been reported in the literature to diagnose CHD. So this figure actually shows those modalities. So we have echo, we have X-rays, we have pulse oximeter, we have CT scans, ECG, and so on. So the best one is echo. But now the question is, for like there is a baby and he or she has a problem. So like echo needs very expert kind of people to diagnose, and unfortunately these are not available in the rural areas, in the far areas. So for that reason, like if there is a baby and he or she has CHD, then if he or she is not shifted to some sophisticated kind of hospital, so his CHD will not be diagnosed. So this is a main problem with the CHD. Okay, so actually it requires early and accurate diagnosis, and traditional diagnostic tools are costly and expert dependent. Like echo is expert dependent, ECG is expert dependent. So for that reason, we actually try to develop an AI-based framework which can detect CHD with a simple signal, and that is pulse oximeter or the PCG of the heart sound. Now, to train a machine learning model for CHD, so we need data. So this is basically a typical diagram of training a machine learning model. So we have data, and for data, then if there is any noise, we remove the noise, and if there is maybe some other step needed, we do those steps in the data preparation. Then the next step is feature extraction, and then training a model, and then prediction. So we have a conventional machine learning model and we have a deep learning model. So in the conventional machine learning model, we do normally feature engineering, and in the deep learning model, no feature engineering are actually done. So actually the CNN do the feature extraction for us. So this is a typical model of the machine learning. Like if we want to train a model, we need training data, and then we do the pre-processing, and then we do the feature extraction, and then the model building. So as I told earlier that this is a very complex problem, and we have 35 different kinds of CHDs. But unfortunately, not only for 35, but for two-class problem, we have very few data. So as an initial step, we just try to classify this to a two-class problem, just CHD and not 𝗔𝗐𝗔. So this is just a two-class classification problem. And what we actually tried, that we develop a stethoscope, and we put a stethoscope on a baby's heart, and then the stethoscope tell us that if the baby is normal or not normal. So that's it. I mean, like just classifying based on the PCG sound, based on the murmur of the baby's heart, classifying a baby is a normal baby or not. Now, when we started research on this problem, so we noticed that, like, when I'm training a model, so I need training data, and there are no free data set available in the literature. So we contacted with some of the hospitals in Pakistan. For example, Pakistan Children's Heart Foundation and some other hospital in 𝗏𝗏𝗺𝗵𝗏 to gather data from the patients. So for that, we need this kind of stethoscope. So this stethoscope is actually do recording of the heart sound. But unfortunately, the price of this stethoscope is around $500. So now and this is a main issue. So as an initial step, what we did, we actually tried to build our own stethoscope which can do this recording for us. So we designed this simple stethoscope for PCG data recording, and we designed this stethoscope with the help of this Benchmarking Technologies Private Limited. So we took help from them, and we designed this stethoscope. So the idea is to put this stethoscope on a baby heart and then connect this to the mobile through Bluetooth or through this wire, and then all the recording of the baby heart will be here. So the data for the normal patient or abnormal patient will be here. So like instead of taking the stethoscope which I earlier talked, we design our own stethoscope with this strategy. Now, in our initial from our initial study, we decided to use three kinds of data. The data from the ponocardiogram or the PCG data, the data from the ECG or electrocardiogram, and the saturation level. So what we were thinking, and this is based on the discussion or discussion with the doctors from the Pakistan Children's Heart Foundation and from the AFIC. So we decided to train our model based on these three features: the PCG data, the ECG data, and then the saturation level. So we were thinking to combine these three features to a single unique feature vector and then train a model. So our database building is still in process, and we collected some data, but the data is not that much. I mean, we cannot train a classifier on that. And fortunately, last year there was a data set, 𝗏𝗔 sound data set from, so this is also, it has been released from one of the hospital from China. So we contacted them and they provided us the data set. But in this data set, we have only the PCG recording, not the ECG or saturation level. And they collected this data set from 1,259 different babies. And the age of all the babies is below 14 years. So we have two kinds of recording, the high quality and the 𝗏𝗏𝗏𝗏𝗏𝗏. So high quality is from 941 patients, and the 𝗏𝗏𝗏𝗏𝗏 data is from 318 patients. And they actually reported only 5 kinds of CHD, the ASD, VSD, PDA, PFO, and normal. But this is one of the best data set that can be used, and it's free for research. So we contacted them, and then we started training our model based on this data set. So this is the strategy which we developed to train our model. So we have 3 tasks. Task 1 is binary classification. That means classifying CHD and non-CHD. Very simple. Task 2 is multi-class classification, but that is for the clean sound. Okay, so we have CHD and non-CHD for the clean sound. And then in task 3, which is 2.1, we classified that for the low quality heart sound, 𝗕𝗑 versus not 𝗕𝗑. And as you saw previously, that we have clean recording and we have some recording with noise. So this is for the second scenario. And then for multi-classes, we also did the same, the 𝗕𝗑 and versus not 𝗕𝗑. So the data in which is coming from the ch sound data set is like the second module is the data is very noisy. So what we did, we basically do pre-processing, and for that we actually converted the PCG recording to the ML spectrogram. So like we have this recording, so after pre-processing and performing many steps, we actually converted this signal to something like this one. So this is actually enhanced ML spectrogram, and then we train our model based on that signal. And this is the model which we used in one of the latest papers, the vision transformer based model. So here we can see that we have actually a CNN module and we have a vision transformer module. So we use the CNN for feature extraction, and then for further steps we use this vision transformer model. So here we can see that we do classification of the 5 signals: the normal, PFO, SD, VSD, and PDA. So as an initial step for feature extraction, we use depth-wise separable CNN architecture shown here, which basically capture the local time frequency patterns from the data. The details of this can be studied in the reference paper at the end of this presentation. So like we published many works on that topic, but this is from one of the latest work on 𝗕𝗑. So this is actually the architecture which we use for the feature extraction. So we have ML spectrogram, we have one convolution layer, then second convolution layer, third, and so on. So and then at the end. Since data is a main problem with us, so we have very less data, so we adopted this strategy of cross validation: 60-20-20, 60% for training, 20% for validation, and 20% for testing purposes. And this is the mathematical description of that. So we adopted this strategy, and with the help of that, there is you can see no conflict of the training and the testing and the validation data with each other. So the results which we got from our vision transformer model for binary classification are really excellent. We got around 95% accuracy, which is really good. And for multi-class, however, we don't have good results. And there are different reasons. So like one of the main reason is the data set which we have in hand is very highly unbalanced. So here you can see that in some cases we have very few samples. Like here we have only 11 samples. Here we have again very few samples. So this is one of the main reason. And the other problem was we have most of the data which is actually noisy. So even though we applied some pre-processing methods, but I think we need some working on that, and we need some signal processing experts who can address this issue in a more proper way. So the results for the binary classification are really excellent, but for multi-class classification problem, we need further working and further research. So we have good results for the precision recall, F1 measure, and accuracy for binary classes, but for multi-classes we have again not very good performance. So here you can see that we have comparatively poor results. Similarly, the same thing can be noticed for multi-class problem. So the summary is we need to address the multi-class classification problem in a much better way. However, for binary classes, the results are comparatively better. So the summary is congenital heart disease is not a very explored problem, not only by my machine learning experts, but medical practitioners as well. So we propose many algorithms. So one of the best algorithm is the hybrid CNN VIT model, which is very effective for 𝗕𝗑 screening. 𝗕𝗑 can be is preventable but only with early screening. When it's too late, then the treatment of the babies is very problematic. So from our study, we conclude that it is better to treat the babies with CDs in the early stage of life. So AE plus sound is one of the scalable solution which we can use. Just combining the machine learning or the AE and the PCG data. So at least it can tell us about the condition of a baby, if it is normal or not normal. So, and we noticed that for binary diagnostic, we have excellent performance, about 95% accuracy. However, for multi-class, performance is comparatively poor. For in future, what we can do, we can include, so data set is one of the main problems. So for that, we can use data augmentation. And some of the data sets where we have some data, but unfortunately the data is very noisy. So noise reduction is the other line which we can explore. And balanced data set is another issue which we can address. So like in the ZCH sound, some classes have very few samples. So we can maybe use the data augmentation, or we can use generative AI for sound augmentation to create somehow a balanced data set. And telemedicine integration is another aspect which we can explore in future. So thank you so much. And so if there is any query, I'm sorry, I'm not able to, due to conflict of some lectures, I'm not able to come online and deliver this lecture in online mode. But anyways, if there is any question regarding this topic, you can approach me at khalil.khan@nu.edu.kz. Thank you so much. Jazakallah.